Good morning, 11th class. Today our topic is spectrum. This one is again important topic and interesting topic, although you are all familiar with spectrum, but in 11th class we'll study with atomic spectra also. That one is new for you. Okay, now simple in case of spectrum. Okay, होता क्या है स्पेक्ट्रम? नाउ जस्ट सी सिंपल. आई थिंक यू हैव डन दैट थिंग कि क्या कहते हैं, व्हेन वी पास वाइट लाइट थ्रू अ प्रिज्म, then it splits into 7 color. That one is known as Vibgyor. Simple. Okay, now just see, this one is your spectrum. Okay, now this one, it's a source of light. When it's passed through a prism, okay, then it is split into 7 colors, or either you can say it is split into different colors. That one is violet, indigo, blue, green, yellow, orange, and red. I think you know. Okay, the short wavelength is of violet and long wavelength is of red. Okay, so this one is simple spectrum. Okay, that one is, just see, in this different colors are formed. Just see, red color, orange color, and they all are in a continuous form. ओके, विदाउट लीविंग एनी गैप और समथिंग, एक दूसरे में कैसे मर्ज हैं. तो दिस इज बेसिकली द सीरीज ऑफ दिस कलर बैंड. दैट वन इज नोन एज स्पेक्ट्रम. ओके, सिंपल. वाइट लाइट पास थ्रू क्या कहते हैं, प्रिज्म, इट स्प्लिट इनटू डिफरेंट कलर, आइदर यू गेट स्प्लिट इनटू 7 color. तो दिस सीरीज ऑफ कलर बैंड्स, दैट वन इज नोन एज स्पेक्ट्रम. एंड दिस स्पेक्ट्रम, because just see, the one color is merged on another one, okay, another one without leaving a gap. So this type of spectrum is known as continuous spectrum. Okay, लगातार है, continuous है, okay, without any gap. Now this one is continuous spectrum. Now we have another type of a spectrum. That one is, okay, known as discontinuous spectrum, and that mainly, okay, atomic spectra. Okay, that one is generally a type of not continuous spectrum, or you can say discontinuous spectrum. Okay, so we'll study about atomic spectra. Our main emphasis on this one, because simple spectrum we have already done. Okay, learn. Now just see, in case of atomic spectra, okay, if just see, according to their name, atomic spectra, okay, means whenever that light is passed through, either it's a matter, either it's a atom, either it's a molecule, either it's an ion, then after that what was the effect. Okay, that one is related to atomic spectra. So now just see, the spectra of atom is not continuous. Okay, just like previous one, it's not continuous. The spectra of atom of sharp well defined lines or bands corresponding to definite frequency, such as a spectrum, okay, is called line spectrum, because इसमें जितनी भी lines आपको मिलेंगी कैसी होंगी, perfect होंगी. Okay, so that, or discontinuous spectrum, because this one is not continuous, just like in previous case. Okay, that one either you can say, okay, discontinuous spectrum or atomic spectrum. Simple. जो भी हमें स्पेक्ट्रा किससे मिल रहे हैं, व्हेन वी पास लाइट थ्रू एटम, either molecules or ions, means when we pass through a matter, okay, then which type of spectrum you get, that one is known as, okay, that is line spectrum or atomic spectrum, because their frequencies are definite. Okay, now just see, in this, on this basis, again spectrum are of two type. Okay, one is emission spectra and another one is absorption spectra. The first I'll explain absorption spectra to you, and after that, on that basis, I'll explain emission spectrum also. Okay, now just see, in case of absorption spectrum, okay, now just see, simple absorption spectrum, this one is normal. Okay, now this one is a sunlight, it's a source of white light, either you can say it's a sample. Okay, NaCl, either sample, you can say that one is a liquid, either it's a gas, it's your wish, no problem. Okay, now just see, when you pass this light through this solution, okay, what happen, हमने पहले भी पढ़ा था, हम किसी मैटर से जब लाइट पास कराते हैं तो जनरली दैट लाइट इज कंसिस्ट ऑफ डिफरेंट वेवलेंथ, काफ़ी सारी चीज़ों से मिलके बनी है. ओके, देन वन, तो आइदर दिस मैटर, either it absorbs some of the wavelength of light, something, कुछ को absorb करेगा, कुछ को transmit करेगा, and कुछ को क्या कर लेगा अपने उसमें, that one is reflection shows. Okay, so now in this case what happened, that this sample, okay, absorb light of some wavelength, we don't know कौन सी करी है, बट उसने क्या करी, कुछ लाइट को क्या कर लिया, एब्जॉर्व करा. कैसे पता चला कि उसने एब्जॉर्व करा? नाउ आफ्टर दिस, when this light is passed through a prism, just see, and when observed on a photographic plate, then it gives a spectrum. Okay, and that spectrum is like what? It's a photographic plate. Now in this spectrum, okay, normally it's a continuous it's a like a continuous spectrum, but separated by a dark line in between. Okay, separated, all are color, but in between it's a separated by dark line. Just see, it's like this one. It's a continuous color with few dark lines in between. It shows what? Ki this sample, that NaCl or whatever is your sample, that sample absorb, okay, the light of these wavelength. जो आपको black black दिखाई दे रही है, उस sample ने क्या करा? उस wavelength की light को क्या कर लिया? Absorb कर लिया. That's why that light is not visible on photographic plate. Okay, क्योंकि अब जब उसने absorb कर लिया तो वो आगे क्या हुई? Reflect आपकी नहीं हुई. Okay, now just see. So this type of spectrum is known as absorption spectrum. Those who are formed by absorption of what? That one is light of some wavelength. So simple tha phenomenon. This one is passed through a sample, then after this it passed through a prism. The sample absorbed some of the some light of some wavelength. Okay, and when you see this in photographic plate, so this type of spectrum is obtained. Okay, it's a normal color along with certain black lines. Okay, now just see. So this one is regarding to absorption spectrum. Now another one is emission spectrum. Okay, now regarding to emission spectrum, okay, 11th class, remember one thing, that emission spectrum is possible only. Okay, this one is a diagram of emission spectrum. Now emission spectrum is possible only when the particles are in excited state. ओके जो भी आपका मैटर है, जो भी चीज़ है, एटम, मॉलिक्यूल्स, कुछ भी हो सकता है. ओके, दैट वन इज इन एक्साइटेड स्टेट. ओके, नाउ एक्साइटेड स्टेट कैसे? एक्साइटेड स्टेट मीन्स व्हेन देयर एनर्जी इज मोर देन नॉर्मल वन. इसमें एक सिंपल सा एग्जांपल ले सकते हो. हैव यू सीन, जैसे कभी फुटबॉल या कभी कोई मैच वगैरह खेलते हैं तो उसमें जब जीत जाते हैं तो योर एक्साइटेशन लेवल इज़ डिफरेंट. हम नॉर्मली क्या करते हैं, जो प्लेयर्स होते हैं वो क्या करते हैं, देखना, नॉर्मली ग्राउंड लेवल से ओके दे जंप सो हाई. ओके, दैट टाइप ऑफ एनर्जी, मतलब नॉर्मल से मोर एनर्जी. तो इन केस ऑफ इलेक्ट्रॉन्स ऑल्सो, in case of atoms, in case of other thing, okay, in that case also they also have excited state where the energy is more as comparison to ground state, normal one. Okay, now how that excited state acquired, कहाँ से आई है? Okay, either when we provide heat, आइदर इट्स अ लाइट, आइदर सम अदर थिंग, कुछ भी एनर्जी आपने प्रोवाइड करी तो उन्होंने उस एनर्जी को एब्जॉर्व करा और वो कहाँ चले गए? हायर लेवल में चले गए. ओके, बट दैट एक्साइटेड स्टेट इज़ नॉट फॉर अ लॉन्ग टाइम. बहुत शॉर्ट पीरियड के लिए होता है, उसकी ज़्यादा लाइफ वो नहीं है. ओके, बिकॉज कितनी देर तक रह सकते हैं उसमें. आफ्टर दैट, ओके, आफ्टर लूजिंग दैट एनर्जी, दैट इलेक्ट्रॉन और आइदर दैट एटम्स और आयन, दे हैव टू कम डाउन. उन्हें क्या करना पड़ेगा? वापस आना पड़ेगा, बिकॉज दिस एक्साइटेड स्टेट फॉर ओके फॉर फ्यू सेकेंड्स, और बहुत थोड़े से टाइम के लिए होता है. ओके, तो नाउ व्हाट हैपन? नाउ सपोज वट एवर इज योर सैम्पल, इट्स अ एक्साइटेड सैम्पल. ओके, नाउ आफ्टर लूजिंग एनर्जी, okay, it comes down to the original state. Okay, तो in case when that light is emitted, जो रेडिएशन इसने जो है वो क्या करी है? एमिट करी है. when that radiation is passed through a prism, okay, and that prism again pass through a prism, then if you will see that thing in a photographic plate, so this type of spectrum is obtained. Okay, this spectrum is mostly black, okay, with certain colored line, not much, it's a spectrum is black with certain colored line. Okay, and it was observed that इन्होंने क्या ऑब्जर्व किया था कि whatever is the lines missing in the absorption spectrum, जो एब्जॉर्प्शन स्पेक्ट्रम में मिसिंग थी. ओके, अगर हम एक ही सैम्पल की बात करें, इट्स नॉट फॉर डिफरेंट सैम्पल. ओके, इफ दिस वन इज फॉर सेम सैम्पल. ओके, तो वट एवर इज द लाइट वेव मिसिंग दिस साइड, जिस वेव लेंथ की लाइट मिसिंग थी इसमें, ठीक है, द सेम लाइट ऑफ दैट सेम वेव लेंथ, ओके, अपेयर्ड इन एमिशन स्पेक्ट्रम. जो उसमें एब्जॉर्व करी थी एमिशन स्पेक्ट्रम में, वही वाली लाइट हमें क्या हुई है? विजिबल हुई है, एंड अदर आर सेपरेटेड बाय डार्क लाइन. Okay, so this one is a simple emission spectrum and this one is absorption spectrum. Hope so difference is clear to you. Okay, now and the C. Now another thing is, this shows that spectrum is a very important thing for knowing what that the particle nature of wave or light की इसने क्या बताया था आपको कि light have particle nature. Okay, although we know that now light have dual nature, particle as well as wave, but this spectrum shows particle nature of light. Now another thing is, this spectrum helpful in knowing the atomic structure of a particular atom. Okay, although सारे एक्सपेरिमेंट इन लोगों ने किस चीज़ पे किए थे, हाइड्रोजन में, बिकॉज दैट वाज द अर्लीस्ट एलिमेंट जो हमें सबसे पहले मिला था. तो सब ने एक्सपेरिमेंट किस पे करें, हाइड्रोजन पे जनरली. ओके, बिकॉज अच्छा दिस वन इज़ वेरी इंपॉर्टेंट फॉर एटॉमिक स्ट्रक्चर एंड ऑल, बिकॉज ऑन दिस बेसिस दे कैन गिव द डिटेल ऑफ देयर स्पेक्ट्रम. वाई? बिकॉज each element have their unique spectrum. जितने भी आपके elements हैं, they have their unique spectrum, and for other element their spectrum is different, both emission as well as absorption spectrum. Okay, that's why this thing spectrum was helpful in knowing, yeah, now it is helpful in knowing the, okay, atomic structure of different atom. Okay, then thank you.